GAC China has developed what it claims to be the world's first ammonia engine for passenger cars. The ammonia engine aims to reduce emissions by around 90% compared to conventional fuels. Ammonia is seen as a potential clean fuel for various modes of transportation. Ammonia is easier to handle and store than hydrogen, as it is liquid at ambient temperatures and doesn't require compression or cryogenic liquefaction. GAC's 2.0-liter ammonia engine has a peak power output of 120 kilowatts, 161 horsepower, and significantly reduces carbon emissions. Previous ammonia vehicle projects have either cracked ammonia into hydrogen or used modified combustion engines. Challenges for GAC include the lack of infrastructure for fueling ammonia and the high levels of NOx emissions associated with ammonia combustion. The engine may still use another fuel source in addition to ammonia. GAC's ammonia engine concept is in its early stages and faces obstacles before becoming a practical solution for passenger cars. Australian startup Synchron has developed a brain-computer interface called the Stentrode, which can be implanted without cutting a hole in the skull. The stentrode is inserted through the jugular vein and steered through the brain's blood vessels to the motor cortex, where it is deployed like a self-expanding stent with 16 electrodes. The stentrode allows for wireless and instant control of devices by reading electrical activity in the brain. The approach is considered minimally invasive and avoids complications associated with traditional brain implants that require skull penetration. Synchron has conducted successful trials with patients suffering from motor neuron disease, enabling them to control computers with their minds. The stentrode is fully implanted and does not have any exposed wires or cables, reducing infection risks. The device has received funding from organizations including the Gates Frontier and Bezos Expeditions, and Synchron is working towards pivotal trials and FDA approval for medical use. While the initial focus is on medical applications, the stentrode could potentially be used for human augmentation in the future. Synchron aims to provide communication and independence to disabled patients and improve their quality of life. The company is ahead of competitors like Neuralink and emphasizes the importance of multiple players in advancing brain-computer interface technology. Synchron's approach has received recognition, including being named a finalist at the 2023 European Inventor Awards. The Grain-weevil grain bin management robot has been developed to assist farmers with tasks inside grain bins. Farmers need to level piled-up grain, break up crusts and bridges, pull down grain along the walls, and push grain into extraction augers. Manual shoveling of grain in bins is a difficult and risky job, exposing farmers to hazards such as entrapment, burial, auger accidents, and lung disease. The Grain-weevil robot was created by Chad and Ben Johnson in response to a challenge from a farmer friend. The robot measures 20 by 20 inches and weighs 50 pounds, using motorized augers to move through the grain and redistribute it. It currently operates at a similar speed to a person with a shovel and is remotely controlled with human-initiated autonomy. The goal is to make the robot level 2 autonomous by the end of the summer, capable of performing tasks while being supervised by the farmer. Safety regulations and certifications need to be addressed before a widespread release of the Grain-weevil. Grain bins are considered hazardous locations due to dust explosion risks. The final price of the robot will be determined after safety certifications are completed to ensure a quality and safe product. Cambridge scientists have developed a prototype for a new form of computer memory, using barium bridges between films of a disordered material. The current binary system of computer memory limits data encoding to only two states, 1 or 0, requiring data to be shuttled back and forth between different parts of a computer system. The new memory system, called resistive switching memory, can create a continuous range of states by applying an electrical current to certain materials, allowing for more efficient storage of data. The prototype device uses hafnium oxide as the main material, with the addition of barium, forming structured bridges between stacked thin films of hafnium oxide. The barium bridges create energy barriers that control the electrical resistance of the material, enabling multiple states to exist in the memory, unlike conventional binary memory. The device has potential applications in AI and machine learning fields, as it can store and process information in the same place, similar to the synapses in the human brain. The device has advantages such as self-assembly at low temperatures, and the use of materials already widely used in the computer chip industry, making it easier to incorporate into existing manufacturing techniques. Feasibility studies will be conducted to evaluate the performance of the materials at larger scales and advance the path to commercialization. The Inflatable is a new type of bike helmet that can be deflated and rolled up for easy storage and portability. It is being developed by a German startup and features TPU air chambers covered in an abrasion-resistant fabric. The helmet can be inflated and deflated using valves in the back, and it takes approximately 20 seconds to inflate. The Inflatable is lighter than traditional helmets, weighing 140 grams (4.9 ounces). In the current prototype, it offers better flexibility and comfort by conforming to the rider's head contours. Unlike foam-based helmets, the Inflatable does not get damaged by impacts and can be reused after crashes. The helmet is claimed to provide 4 times the shock absorption of conventional foam helmets. It is expected to receive full European safety certification later this year. Pre-sales for the Inflatable helmets are set to begin in August, with shipping planned for November. The estimated price for the helmet is around €150, US $163, subject to potential changes due to supply chain issues. Ultimate Ears Pro has partnered with Knowles Corporation to release the UE Premier in-ear monitors, which feature an impressive 21 drivers per earphone. The UE Premier EAMs are the first in the industry to have 21 drivers with a 5-way passive crossover design, including 8 Knowles dual diaphragm balanced armature receivers and 4 Knowles super tweeters. Each driver is individually tuned for accurate reproduction of different frequency bands, offering a frequency response from 5 Hz to 40 kHz. The custom shell of the earphones is 3D printed based on impressions created by an audiologist or digital ear scans, ensuring a secure fit and optimal passive isolation. The UE Premier in-ear monitors are targeted towards gigging musicians, studio producers, and demanding audiophiles. They are available in various colors and priced at $2,999. Canadian company Volt Lithium has developed a low-cost lithium extraction method called direct lithium extraction, DLE, to extract lithium from low-concentration brines. DLE is a faster and more efficient process compared to traditional brine evaporation methods, extracting up to twice as much lithium from a given brine. The DLE process uses a highly selective absorbent molecule to capture lithium from the brine, separating it from water and impurities. Volt Lithium's pilot program achieved high lithium extraction rates of 90%, from low concentrations of 34 mg per liter and 97%, from concentrations of 120 mg per liter. Volt Lithium plans to convert old oil fields into lithium production operations, extracting lithium at a cost of around $3,000 per metric ton. DLE technologies have the potential to significantly increase global lithium supply. Researchers have developed a wearable, non-invasive sensor called Inflatable that can monitor a biomarker of inflammation in sweat. Chronic inflammation is associated with various mental and physical disorders, and detecting it is crucial for treatment. Inflatable measures the levels of C-reactive protein, CRP, in sweat, which is a biomarker of inflammation. The sensor overcomes challenges related to detecting CRP, such as its low concentrations in the blood and difficulty in secreting it into sweat. Inflatable is made from laser-engraved graphene with tiny pores containing antibodies that bind with CRP and special redox molecules. When CRP molecules enter the sensor, they attach to the antibodies, triggering the redox molecules to generate an electrical current. The sensor was tested on healthy participants, COPD patients, and post-COVID individuals, accurately detecting sweat CRP levels that correlated with blood levels. Inflatable could be used for non-invasive, at-home monitoring of chronic diseases like inflammatory bowel disease or COPD. The technology has the potential to be adapted for testing other trace level and disease-relevant biomarkers.